Okay, so now we're going to talk about mappings and functions. I had an example with a finite set. It was two ordered pairs, if I'm remembering right. It was like this, okay? Well, to make a mapping, sometimes we use ovals, sometimes I'll use rectangles. Usually you see ovals. Pretend like those are ovals. Anyway, you list the domain in the first oval, so 1 and 2, those are the domain elements, or the first components. And then the range elements are going to go in the second oval. It could be a rectangle, though. 0 and 1 are the range elements. Well, the mapping shows what goes to what. So the 1 goes with the 0, and the 2 goes with the 1. So that's an example of a mapping. Yeah, now I'm going to give you another example. Let's say you have 1 and 2, and let's say you have 3, 4, and 5 over here. And so let's say you have 1 mapping to 3, and maybe 1 also maps to 5, and maybe 2 maps to 4. Okay? You could list the domain, you know it's 1 and 2. You could list the range, 3, 4, and 5. And then you could actually form the ordered pairs. The ordered pairs would come from how many lines you have here, how many arrows there are. So, well, I just drew another arrow, but you have one ordered pair, which is 1 going to 3, and you have another ordered pair, 1 going to 5, and then you have another ordered pair, 2 going to 4. So there are 3 ordered pairs. Mappings only work for finite sets. Okay, but they show what goes to what. It's kind of a visual. Okay, some mappings are functions and some aren't. To be a function, you know what? They have 2 definitions in the book, and I was going to try to give you both, because sometimes it's hard to come up with that formal definition or understand it. So, okay. I'm saying this like in my mind 2 different ways. Okay. You can't have the same first component going to different second components. Okay? So right away, I'm just going to tell you, this is not a function. It's not a function because the 1 is going to the 3 and the 1 is also going to the 5. And that's what you can't have. You can't have the first component going 2 different places. Or 3, or it has to only go to 1. So another way to say this is each domain element maps to only one range element. And you can look up the formal definitions in the textbook. Okay? So is this a function over here? Yeah. Each domain, so I've got a 1, it only goes to 0. I've got a 2, it only goes to 1. So yes, this is a function. I'm going to give you one more example. Let's say you have a mapping that's got 5 and 6, and over here you have a 7. So say the 5 goes to the 7 and the 6 goes to the 7. So what does that look like? It's the set of ordered pairs 5, 7 and 6, 7. Is that a function? What do you think? Yes or no? So stop the video and think about it. The answer is it's a function. Yes, a function. A lot of times they'll say, is this a function? Yes or no? Okay, because each of my domains only go one place. They go to the same place, but that's okay. You can't have the 5 going to 2 different places or the 6 going to 2 different places. You can only go to one place. Okay, so here we go. Determine whether each relation is a function. These are both finite, just a set of ordered pairs. So here I have a 1, 6, a 2, 6, a 3, 8, and a 4, 9. Sometimes it's really easy to see this with a mapping. So I'm going to go ahead and do a mapping just for fun. You don't have to. I'll show you another way to do it. 6, 8, and 9. So we're saying the 1 maps to 6, the 2 maps to 6, 3 maps to 8, 4 maps to 9. What do you think? Function, yes or no? Yes, because each domain is only going one place. All right, now we have this other relation. So what do we have in the domain? 6, 8, and 9. What do we have in the range? 1, 2, 3, 4. Okay, so 6 maps to 1, 6 maps to 2. Okay, it's not a function because 6 is going to 2 places, so no, not a function. Okay, I didn't even finish my mapping. 8 goes to 3 and 9 goes to 4. All right, and it only takes one, mistake, I guess. It's not a mistake. It's just one set of ordered pairs, like one domain element going 2 different places. So the others were fine. The 8 and 9 were fine. But the 6 is going 2 different places, therefore it's not a function.